Okay, welcome everyone to tonight's presentation of our virtual star party. We're going to get started here in just a minute. We'll start with some discussion and visual aids of the equipment that we're using tonight, and then a little bit about the night sky using two planetarium programs. One is Stellarium and the other one is Sky Safari Pro. And then we'll jump in and start looking at some objects. So let's start with Bernie. Why don't you tell us a little bit about the telescope you're using out at CAC?
All right. My name is Bernie Stinger. I'm a four-year member of the Tucson Astronomical Association. And I'm out at our deep sky site just west of the Chiricahua Mountains in southeastern Arizona. And our deep sky site is what we call the CAC for Chiricahua Astronomy Complex. And one of the telescopes that we have here permanently mounted is what you see in the image here. This is a 9-inch refractor, but this is a special refractor. This is a folded refractor. So the imaging part of it, the 9-inch lens is up at the top, and then the light comes down, bounces off a mirror, comes back up again to where the camera is located. So the camera will be located just above where you got the arrow there, Jim. And that's where the camera is located that I'm using tonight. Now this is on an Astrophysics 1600 mount. This is a high precision mount, and it has excellent tracking. So it's very, very nice to use, both visually and with cameras. The camera I'm using tonight is a Malincam DS10C with a thermoelectric cooler on it. Now you can't see it in this image, but it's mounted on where the eyepiece would normally be. So that camera is then wired back here through a USB cable to my, I'm inside the warm room just next to the telescope, and it's wired back to my computer so I can bring up live images to show you this evening. Back to you, Jim.
All right, thanks, Bernie. Now we'll take a look at Jim O'Connor's setup. Go ahead, Jim.
What you're seeing are two different views of my setup. One is a little farther back so you can see the whole assembly, and the other is a little bit closer view of the back of the telescope where most of the work's going on. The telescope is a 10-inch mid-Cassegrain, and it's on an AVX Celestron equatorial mount. The camera itself does a lot of the work of getting that image to you. It's a Malincam Exterminator. It's a very high sensitivity CCD camera. It's also got thermoelectric cooling, and it's a color camera. As you can see from the left-hand picture, I just run it with a laptop, but at the right at the camera, or I'm sorry, right at the telescope is a monitor, a 12-volt monitor. And that's what I take on the road. If I go out onto school sites, I don't have to take the laptop with me. I'm only taking that so I can show these videos out onto the internet. So it does a pretty good work. It's normal. It's normally somewhere around 150 to 160 power. I can get it up to 320 power with the software edition. And that doesn't mean much to somebody who doesn't know what the image looks like. It's just that I can go pretty deep, but it's also a very tight view. On the top of the telescope is the finder I use to locate objects in the sky until I get the telescope aligned. And the camera is on the back. You can see it's a pretty heavy camera sitting back there. Most of that is the cooler. It's an actual heat sink. Inside, it's got an electronic thermoelectric cooler that sends it out through the connecting tube that goes into the telescope. It sends that out and it conducts to two fans that are blowing on the outside to get rid of the heat and keep the CCD chips safe. And Jim, back to you.
All right, thanks, Jim. And Rick, go ahead and talk about yours.
Okay, what you're looking at here is my 4-inch refractor. Refractor is all lenses, no mirrors. The very first telescopes that were made were of a very similar design with lenses. I'm on a big, heavy Losmandy mount, also a high precision mount. Very good tracking. Now, what you're seeing on the back of the camera, as you look towards the back of the telescope, you'll see a big flat disc and then a red cylinder behind it. The flat disc is a filter wheel that I can be turned electronically and put different filters in front of the camera. The reason for this is that my camera is a monochrome camera. It does not see color. It only sees black and white. This is very similar to how the Hubble Space Telescope works. It also has a monochrome camera. I can get color images by putting different filters in front of the camera, taking a sequence of images with different filters, then combine them to get color. Then on top of the telescope, you'll see another smaller telescope and a little red device in the back of that. That is my star tracking setup. That little camera picks off a star, and then through the computer, it keeps the mount very accurately trained on that star, so I can take very long exposures without the stars moving around. So that's about it. Back to you, Jim.
All right, thanks, Rick. Now what we're going to do is let me just show you a little bit about where the planets are right now in the night sky. So this is as of tonight. You can kind of see the 4 inner planets, with Mercury being closest to the sun. Venus right now is mostly on the other side of the sun from us. It's currently in the morning, but as it speeds by the backside of the sun, it'll then start popping out in the evening. And then we've got Earth out here, and then Mars is further out from us. And then as we go out further, we've got in between Mars and Jupiter is the asteroid belt. So there's a belt of asteroids going around right in here. Jupiter actually, because of its size, helps to stabilize the asteroid belt and keeps them kind of in place so that they're not flying into the inner solar system. So that's a good thing. So Jupiter and Saturn are the 2 gas giants. Right now, they're kind of on the opposite side of the sun, so they're in the glare of the sun right now. And then eventually, as we speed on by the sun and they start becoming visible again, they'll be out in the morning. And then further out yet is Uranus and Neptune. Uranus is clearly visible. You can see it's on the backside of the sun. Neptune is kind of on the backside of the sun right now, so we won't be able to see it. But we will. One of the first things we'll look at here is Uranus and the moons of Uranus. We'll be looking at that through the 9-inch refractor. And then further out beyond that, Pluto. As we all know, Pluto is now classified as a dwarf planet. One of the reasons, if you look at the orbital plane of the solar system, that Pluto is a little bit different, is if you start looking at the solar system horizontally, you can see that most of the planets are all in the same plane going around the sun. Pluto has a slightly different orbital path. And there's many objects out there in the Kuiper belt that are similar to that. So that's one reason why they don't think Pluto was one of the normal planets around the solar system. It's probably a captured Kuiper belt object. It's leftover stuff, and the largest thing we can see from the Kuiper belt. So that's where we currently are in the solar system. Now let's just take a look at the night sky. This is what it looks like tonight. If you were to go outside and look to the southwest, you'd be able to see Orion the Hunter and the belt of Orion. And then down in this little area down here is his sword. And so tonight we will look at Orion's Nebula, which is down in there. Mars is up, but we're probably not going to look at it because it's so far away and so tiny that you really can't see any details on. So we'll focus on Uranus as far as the planets go. We will look at some galaxies up in Ursa Major, which is the Big Bear. It's also part of it's the handle in the bucket of the Big Dipper. We'll look at galaxy in Camelopardalis, and also we'll take a look at the Triangulum Galaxy in the constellation of Triangulum. And we'll look at some star clusters in Cassiopeia, which is right up here, the Queen. You can kind of see a faint outline of her. Most of the time you see it as a W in the night sky. We'll look at down towards the south. We'll take a look at a star cluster in the constellation Columbia. And then we'll also look a little bit in Taurus, we'll look at M45, which is the Pleiades cluster. And then we'll also look at some nebula in Taurus and Orion. So those are kind of the objects we're going to take a look at tonight. As you can see from an astronomy perspective, this is kind of the map of the night sky that astronomers use. So we divide that sky up into constellations. The pictures that you see reflected here, those are sometimes hard to pick out when you're looking at the night sky. Some of them you can kind of envision what they're looking at, but most of them are pretty hard to pick out. You know, back in the day when these constellations were first devised and brought up, the skies were darker. You probably had more stars visible. They certainly had more time on their hand to do some imagination and things like that. And different cultures have different objects for these things. And Jim's going to talk a little bit about that when he gets to Orion and M42. So that's what the night sky looks like right now. All right, so now what we're going to do is we're going to take a look at our first object, and Bernie's got Uranus in the 9-inch refractor. So Bernie, go ahead and bring it up.
And tell me if it's on the screen.
Yep, we've got it.
Okay. So this is a live image of of Uranus and the field of stars around Uranus. And right dead center, this is the planet Uranus. It's the furthest planet that you can see with the naked eye if you have really dark sky and you know exactly where to look. Actually, I've tried to find it myself. I've never been able to find it just visually with a pair of binoculars, but other people have been able to do that. Fortunately, telescopes will find it for us, so it makes it a lot easier that way. If I zoom in on the planet Uranus, and you can tell, unlike the stars that are around it in the same field, it has a disk shape. It actually has a little bit of a disk to it. And if I zoom in on the planet, I'll stop right there. These are 5-second, no, I'm sorry. These are 3-second exposures. If I zoom in on the planet, you'll see orbiting around the planet, there's 4 little specks of light. This one's a little fainter, but 1, 2, 3, 4. And those are 4 of Uranus's moons. And if you have the right astronomical program, such as Stellarium, then Stellarium or the Sky X or various other planetarium programs will identify which moons those are. So to let you know, this is Uranus. This moon right here orbiting around Uranus is called Oberon. And this one right here is called Titania. And this fainter one is Umbriel. And this one is Ariel. So those are four of about a half a dozen moons that can be seen orbiting the planet Uranus. There's another moon, Miranda. It would be right about here if we could see it, but I'm afraid it's probably too close to the planet or too faint tonight to pick it up. But we did get four of the moons. Now Uranus right now is about 2 billion miles away. So it's a faint object, but it's easily grasped in most size telescopes if you know where to look for it. Now, another thing that I like to show people is the color of Uranus. If I run the exposure down, and the moons are going to disappear now because I'm running the exposure down to a much lower, shorter interval. If I run the exposure down to about, right about there, 7 milliseconds or so, maybe a little less. There we go. You'll notice the blue twinkle of Uranus. Uranus is blue. When you look at it visually in a telescope, most people will notice it has a blue tinge to it. And that's because of the methane in its atmosphere. Its atmosphere is a high concentration of methane. So when sunlight bounces off of Uranus, the reds of the sunlight are absorbed by the methane, and the blues get reflected back at us. And that's why we see Uranus as a blue planet. Neptune is also blue because there's a lot of methane in its atmosphere. But we won't be looking at that tonight. I'm going to bring the exposure back up again, and you'll see the moons pop back out again. It's always fun to watch the moons as they orbit around the planet. Some of them go around faster than others. Back to you, Jim.
All right, and while you have the Uranus up, just a couple things. Bernie said that it's, if you've got some dark skies, it's right at where you might be able to see it with your naked eye. It's right at about 6th magnitude. So the smaller the number, the brighter the object. And with a dark sky, usually a magnitude 6 is everybody's kind of limiting for a pinpoint of light or something like the planet. The light you're seeing here, as Bernie said, it's 2 billion miles away. So at the speed of light, the reflected sunlight, after it reflected off of Uranus, took 167 minutes at the speed of light to get to our eyeballs. So it's 167 light minutes away. Uranus is so far out that it takes 84 years to make one revolution around the sun. So it's 84 times the revolution period as the Earth. It was discovered by William Herschel back in 1781. And like Bernie said, it's kind of one of our giants made out of methane. It's pretty cold out there. The cloud tops of Uranus are about minus 360 degrees Fahrenheit. So that's pretty cold. All right, Jim, why don't you go ahead and share your screen? And we will take a look at NGC 7789, which is Caroline's Rose.
A little bit down there in the lower left section. This is called Caroline's Rose, and it was discovered by Caroline Herschel in 1783, just 2 years after her brother William Herschel had discovered the planet Uranus. It's got a number, it's called NGC 7789. We'll get a little bit to what NGC means in a minute. This is an example of an object called an open galactic cluster. That's dozens to hundreds of young stars. They're all bound together by their own gravity, but most of them are spinning a little bit. They pick up the rotation of the galaxy around them, and eventually they'll drift apart. So we're seeing it. We're lucky to see it like it is now, and like Caroline saw that rose down in the little more leftish part of the picture. They all form out of a common gas cloud, and the gas cloud eventually is either used up or blown away by the stars, and so all that's left is a beautiful collection of stars. This object is just beyond visual range if you could see it, but it's kind of small from the Earth. This is magnitude 6.5 to 6.7. It's in Cassiopeia. It's about 7,500 light years away, and it's estimated to be a little over 1 billion years old. Across that object you're seeing there, that's in the left, let's say the left half of the screen, that's right about 35 light years. When Caroline discovered it, it was about like it was now. It was about 150 stars, and they thought when they looked at the center, it looked like rose petals sticking out. But as telescopes got better, and you could actually take pictures of it and change your exposure times, then something interesting happened. They thought, it was always thought to have 150 stars. But I'm going to increase my exposure here, and we'll see how long it takes to get us a picture, and you can let me know when it fills out.
Yeah, it looks good. It's filling out nicely.
There's actually 1,500 stars approximately in that cluster. Now, we called it New General Catalog, and that catalog was actually created by an astronomer named John Dreyer in 1888. So that's about 100 years, over 100 years after this. And what he did was he took all the astronomical work by Frederick William Herschel, Caroline Herschel, and Frederick's son John over about 75 total years of astronomy experience, and he put them all into one catalog so everybody could get to it. It ended up having quite a few objects in there, about 7,840 objects that the three in the Herschel family had discovered over their long time observing. And the interesting thing is that all this work was going on 20 years after Frederick Herschel had started conducting the Bath, England Orchestra. He really was an orchestra conductor and composer, and he just started working with telescopes because he got told that if he could get the mirrors right, they would have an appearance in images they projected that would be comparable to musical chords. So to be a better composer, he started building telescopes. And on his 6th telescope in his back garden, he discovered Uranus in 1781. He ended up at the end of his life with about 24 symphonies that he had composed and 400 telescopes he built for himself and for other astronomers. Jim?
All right, thanks, Jim. Yeah, that's interesting. It's kind of nice when you can get a little background on the various astronomers and what they when they detected it and when they observed it and how they kind of got into it. All right, next up is going to be Rick, and we're going to take a look at a pair of galaxies called Bode's Galaxy and the Cigar Galaxy.
Okay, give me a second here. There we go. So what you're looking at here is in the very center, you'll see a bright spot there with some glowing around it. that is a galaxy known as M81 or Bode's Galaxy. Then off to the right here, you'll see another long bright object. That is M82, or also known as the Cigar Galaxy. Both of these galaxies were discovered in 1781 by Mr. Johann Bode. The reason they have M numbers is they were rediscovered a few years later and added to Charles Messier's catalog of objects that were not comets. He was keeping track of things that were up in the sky that weren't comets because he was a comet hunter. But he's now more famous for his list of these other bright objects than he is for the comets he discovered. So what you're looking at here is very, very distant compared to the Uranus that you were looking a little bit ago. Bode's Galaxy here is approximately 12 million light years away from us. That is a very, very long ways away. Size-wise, you're not seeing it all here. If I took a longer exposure, you'd see more of it. It's stretching out there a little bit, but the total size of the galaxy, it's about 74,000 light years across. And that goes for both these objects are about the same distance from us. Looking over here at M82, you might be able to pick out that it's not just a bright strip. You'll see some dark patches in it. Those are actually dust lanes in the galaxy that are between the bright stars of the galaxy and us. There's these dark patches of dust that run through them. And that's what you can see there. I think that's about it, Jim.
All right, and if you kind of envision between the two galaxies, between the Cigar and Bode's Galaxy, that distance is estimated at about 130 to 150,000 light years apart. So those two galaxies are relatively close together. Our satellite galaxies around our Milky Way galaxy are probably about 100,000, 75 to 100,000 light years away. So these two galaxies are in fact interacting with each other. And if you were to look very carefully, you might even be able to see a tidal stream between the two galaxies. So that's kind of interesting. They are some, and then the interaction probably happened, probably several hundred million years ago. So it's been a little while, but one of the things you might wonder is how astronomers determine distances to the various galaxies like this. And one of the things they use is what's called the Cepheid variable stars within these galaxies. And the Cepheid variables kind of vary, they're variable in their brightness to a certain cycle that is determined. And by looking at that, they're able then to be able to estimate how far these galaxies are away. So that is Bode's and Cigar in Ursa Major.
What we're looking at here is an interesting open cluster that's called the Owl. And the reason it's also got a number, NGC 457. The reason it's called the Owl is that some people think they see a pointless view of an owl spreading its wings. Its feet are at the lower left, and at the upper right are two very bright stars that are its eyes in there. And it's a magnitude 6 open cluster in Cassiopeia. William Herschel found it in 1787. It's about 8,000 light years away from us, so it's a healthy distance away to see to be able to see an open cluster. So those stars are only about 22 million years old, yet they don't have a tremendously long life to see, at least of the ones we're looking at, because they're so big. There's an estimated 150 stars in the cluster. It makes a circle of about 30 light years in diameter. But a little secret about it is those two stars that make up the eyes are only 4,000 light years away. So they're only about half the distance to that main one. But without those eyes, we wouldn't have the owl. And what I might try here is an experiment. And I shifted the image down so I can manipulate it a little bit. And when it will go away, and I hope come back, you can see just the eyes will start out, and then its body will slowly fill in. Sometimes that makes it easier to see it as an owl. And now we see him waving. At Halloween, I show that in front of my house on Halloween, upside down, and I call it the bat. And as soon as we finally get that image in there, that's about all I got to say about this guy. It's a lot of entertainment at elementary schools and middle schools.
Yeah, that's one of the objects that actually does kind of look like what it's purported to be. That's kind of a cool trick where you'd start off with the eyes and let things kind of fade in. It really made it show up. You see the wings and the legs show up a lot.
All I had to do was change the, right now that's 2.13 seconds of integration time. I had to drop that to 2 seconds. That's all it took, and the camera started to redraw it.
Right. And sometimes this cluster is also called the ET cluster for extraterrestrial.
Oh, yeah.
Because of the bright eyes kind of staring back at you.
And it's also called the Kachina doll in some societies, and the dragonfly. I actually was at a star party and showed this once at a camporee on Davis Monthan Air Force Base, and half of the scouts that looked through my telescope swore it looked like an F-15.
Yeah, I guess you got to take it into context with the environment.
But as you can tell, as it started integrating and building the picture, you could see it actually form an owl.
Yeah. All
there
right.
he goes again. He's cycling through. That's it for my guy.
All right, Bernie, let's take a look at Galaxy and Camelopardalis.
And are we getting my screen?
Looks good.
All right. So what you're seeing now is a spiral galaxy, a very traditional spiral galaxy. It goes by the unexciting name of NGC 2403. NGC stands for the New General Catalog. And it's object number 2403 in the constellation Camelopardalis. This is a somewhat of an unusual spiral galaxy in that it has a lot of star forming going on, and that's why I wanted to show it this evening. It's about 8 million light years away, so it's relatively close as far as galaxies are concerned. The Andromeda Galaxy, being 2.5 million light years away, is our closest galaxy neighbor. So this one isn't that much farther away. However, it's not part of what we call the local group of galaxies. This one is a member of what's called the M81 group of galaxies. It was first found by William Herschel back in 1788 when they were doing their sweeps with telescopes, and they were the first ones to find things up in the sky. Later on, Edwin Hubble detected what's called Cepheid variables in this galaxy with his big, huge Hale telescope. and because of that, was able to determine that the galaxy is 8 million light years away and about 50,000 light years in diameter. Now, as I mentioned, this galaxy has a lot of what's called star-forming regions. They're also known by amateurs and professional astronomers as H2 regions. That means, in essence, that those areas have a lot of ionized hydrogen. Now, if we zoom in on the galaxy, you can see some of those areas. First of all, I want to point out these bright spots are foreground stars. These are stars in our galaxy that we have to look through, because we have to look through the stars of our own galaxy to see distant galaxies. So these are foreground stars. They're much closer. They're in the tens or 20,000 light year range. This is millions of light years away. And if we zoom in on it, you'll notice these kind of bright, blurry spots. Some of them even have a bluish tinge. They're all over the place in the galaxy. There's some more down below. Here's a big one down below as well. Here's another one, another one, another one. They're all over the place in this galaxy. These are called star-forming or H2 regions, and they represent hydrogen gas that is forming into stars. So within these big clouds of gas, new stars are being born. And those stars will glow very brightly with a bluish tinge. And you'll notice some of these star-forming regions actually have a little bluish tinge to them because of that. They output a lot of ultraviolet light, those new stars. And when they do, that ultraviolet light ionizes the hydrogen gas that's around that star and makes it glow. And that's why these areas glow, why these clouds of gas glow so brightly. They're being ionized by those blue stars. Eventually, those stars, because of their solar wind, will blow the gas away, and then you'll have just stars without the gas, and those stars will be in groups that we call open clusters, one of which Jim just showed you. So that's what a very active spiral galaxy looks like, and this is an excellent example of one with all the numerous star-forming regions. Jim?
All right, yeah, that's a great looking spiral, and it's you know, being relatively close, it's kind of neat that you can see some of the different star forming regions rather than just the spiral. But if you look carefully, you can actually see the spiral arms circulating around. They're not quite as clean as you might see in some of them, but it's got a lot of additional material available.
Pretty obvious arms going around. And then there's got to be another arm connected up with this H2 region, but it's a lot fainter. I can't see it, but there's probably another arm that's extending way down below here as well.
Yep. All right, excellent. Thank you very much. So now let's bounce over to Rick and take a look at a galaxy that's probably about a third the distance away from the one we just looked at, called the Triangulum Galaxy. Rick?
Yeah, there we go. So this isn't as bright an object as what Bernie was just showing you. It's a very dim galaxy. It was not really recognize as a galaxy until we had modern telescopes and modern photographic techniques that could really pull out the detail in it. Even now I'm shooting relatively short exposures on it, so you're only getting some of the detail, but you'll see a bright core in the center here, and you can see some arms, some lightness coming out here, and the whole galaxy is in this region around here. All that lightness there is the Triangulum Galaxy. Now, this is the third largest galaxy in our local group. The other big bright galaxy is Andromeda. Both Andromeda and the Triangulum Galaxies are the most distant objects you can see with your naked eye in our sky. It is possible to see both of these, to spot both these objects. You can spot them both pretty well with a pair of binoculars. So compared to the galaxy that we were looking a little bit ago, we're looking at Bode's galaxy. That was many millions of light years away. This one is only 2.8 million light years away, so much closer. Size-wise, it's similar. It's about 50,000 light years across on this galaxy. When you see this galaxy in color, it's very pretty. It's got blues and pinks in it. It's a very pretty picture when you can see it in full color with very long exposures. This is a spiral galaxy, same as what Bernie was showing you. This one is a nice one to see because it's on a nice angle relative to us. It's not flat on, it's not edge on, it's kind of at a tilted angle. And so it's a very nice angle to look at it with. Jim, you got anything to add?
I might have missed it. Did you talk about this being part of our local group?
Yes. It's
Okay.
I did say it's the third largest of our local group between Andromeda and ourselves in the Milky Way.
Yeah, so it's about 300,000 light years, a little bit further away from Andromeda than it is from us. So it's kind of almost like a satellite galaxy of Andromeda. And the Triangulum and the Andromeda Galaxy will probably merge as Andromeda starts getting closer and closer to the Milky Way galaxy. So in 4 to 5 billion years, the Andromeda, probably with Triangulum in tow, or maybe already merged, in about 4 to 5 billion years will merge with the Milky Way and will become one huge elliptical galaxy. So that's still a ways away, but it'll be kind of interesting. It would be really cool if you were around then to see the Andromeda Galaxy getting larger and larger in the night sky, because the Andromeda Galaxy is about the furthest thing you can see with your naked eye. And to be able to see that kind of growing in the night sky would be pretty awesome. Anything else, Rick?
I was just going to mention that this was discovered in 1654, very early discovery. Again, they didn't know what it was. They didn't know that it was a galaxy. They called everything at this time a nebula. But it was rediscovered over various years, and it is in Messier's catalog as M33, again as a non comet.
Yeah, it was kind of a fluke or fate that Messier was so focused on looking for comets, and he kept coming across these faint fuzzies that he didn't want to mistake as comets, and those turned out to be some of the best images for us to look at. Kind of cool.
What he became famous for.
And what he became famous for, exactly.
Okay, this is an object that actually we talked a bit about Charles Messier. This was the first object he discovered. Charles Messier had an interesting background. He came from a large family farm. His father passed away when he was 11 years old, but there was nothing for him to do on the farm because they had a lot of farm hands. And his uncle was trying to help him find something to do with his life. And so when he was almost 20 years of age, he got him a job with the French Navy as a chronicler of dynamic events. For the French Navy, that meant finding comets because they were superstitious. They believed they should plan their military actions based on comet activities. So that was what he spent the rest of his life doing, was hunting down comets. This is the first one he saw. It's in the constellation Taurus. And he put up the first 40 objects he found. He wrote his first volume of books on the objects, and he put a preface that said, "The object I found, the supernova remnant the crab, had such a resemblance to a comet that I endeavored to find others, so astronomers would not fuse these nebula with comets just beginning to shine." So he didn't want us to get confused, so he's trying to help us out. Later, he only found 103 objects, he and his partner Pierre Méchain. The other objects, 104 through 110, were added between 1926 roughly and 1968 as modern astronomers looked over his observing logs and things that he hadn't put in his catalogs. And so that's how we got the full 110 objects. The Crab Nebula that you're seeing here is what's called a supernova remnant in the constellation Taurus. A supernova can occur from a number of reasons that places a large amount of mass in a volume so small that gravity forces a tremendous nuclear fusion reaction. And in this case, it was a star, a source star about 8 or more times as massive as our sun. And it had been creating more and more heavy elements over its several million year life with fusion reactions as gravity compressed the star. When it started making iron in its core, that stole the rest of the energy from the star, and gravity collapsed it, and it caused a massive nuclear detonation, blowing the debris away. Some stayed behind, though, about as under the amount that of 3 solar masses. What it takes in a supernova to leave one of these things is less than 3 times the mass of the sun. So we know it was sometimes somewhere around that mass left over, and it started out at more than 8 times as massive as the sun. But when you've got that kind of mass, it squeezes the elements that were there so tightly together that they lose their identity and all become neutrons. And it makes an object about the size of a small city. And it's called a neutron star. And it picks up all the spinning that the original gigantic star had. And so it spins pretty quickly. And that extra, all that mass in that little bitty area throws out a whole lot of radiation. And so it's like a lighthouse. It's turning up to several thousand times a second. In the case of the Crab Nebula, the inner star, or the inner star that's left over, the neutron star, is located about 6,500 light years from Earth. The pulsar is about the size of the island of Manhattan, sending out that light that's making all the blown away debris that's expanding shine. And that object we see here was actually seen to become a supernova on July the 4th in the year 1054. The Chinese noted it and made a record of it. And the next morning, it was recorded by some Pueblo culture tribes in Arizona and New Mexico area. What was found on Chaco Canyon, White Canyon, and Navajo Canyon are a sketch of a crescent moon very close to this star that had exploded, the big bright light, because you could see it in the daytime. And what the reason there was a crescent moon was, if you go back to 1054, the crescent moon was only a half a degree away from this explosion in the sky, the visibility. So this is the first one that we actually have records of when it actually happened, because of both the Native Americans in the Four Corners area, and because of the Chinese, who were great astronomers and looking for what they call guest stars, and this was one of the ones they recorded. Okay,
Yeah,
Jim?
and that it's kind of interesting because that one was visible during the daytime for what, about 650 some odd days, so almost 2 years.
23, because Membrae
Oh, that's right.
pottery
That's right.
actually, Membrae pottery has a dancing rabbit that is their symbol for a crescent moon, and it's standing on top of a ball with 23 spikes, and that meant one for each of the days it was visible in New Mexico in the daytime.
Yeah, I guess the 650 some odd days was how long it was visible at night.
Yes.
Yeah, so it would have been just kind of a bright object to be able to see. So I mean, that would have been really cool to be able to see that.
We might with Betelgeuse in another 10,000 years.
Yeah, if we're around for it. Yep, exactly. All right, thanks. So yeah, that's the M1 Crab Nebula.
So this is another NGC object, new general catalog. This is number 1851, and it's a globular cluster. Globular clusters and open clusters. Those are the two kind of star clusters. Jim's been showing you open clusters. This is a globular cluster. Now, why do they call them that? Because they are in a glob, for lack of a better term. They're in one big central concentration. So what you're seeing on the screen here is the globular cluster in the constellation Columba. Now, globular clusters will be concentrations of stars that are maybe in the 100,000s into the millions of stars, all in one big central concentration, with some in the outer lying areas. And if you look around the central core there, and you can't see the individual stars in the core because they're so close together, they just overwhelm the camera. But you can see the stars that are further away from the central core and extending out quite a long distance around from the central core. This particular globular cluster is about 39,000 light years away. Now, there's approximately 150, I think I heard 150 to 160 globular clusters that concentrate around the center of our galaxy. They're kind of like bees swarming around the hive. And those globular clusters are very, very old. This particular one is estimated to be in the range of 9.2 billion years old, which is, considering that the universe right now is considered to be a little over 13 billion years, that means that this globular cluster has been around for a good portion of the time the universe has existed. Now, these globular clusters tend to have orbits around the central core of the galaxy, of our galaxy. And this one has what's called a highly eccentric orbit, kind of like how Pluto goes around the sun. It doesn't go around the same orbit as the rest of the planets. And the same is true for this particular globular cluster. It doesn't go around the central core of our galaxy like the rest of the arms of our galaxy do. So because of that, they feel that this particular globular is actually what's called a stripped dwarf galaxy, meaning that there was a dwarf galaxy, a smaller galaxy that was going around our galaxy, the Milky Way, and in numerous collisions over time, billions of years, that dwarf galaxy had a lot of its stars and gas stripped off by collisions with our galaxy, and the only thing left is maybe the central core of that galaxy. So that's what they think this particular globular cluster is. It's what's left of a galaxy long, long ago that no longer exists. It has about 550,000 times the mass of the sun. So each of the stars in that globular cluster was the size of the sun, there'd be over 550,000 of them. Now, some of those stars are bigger, some of them are smaller. So it's really hard to say exactly how many. But this one looks like it's in the range of 500,000 stars. And back to you, Jim.
Yeah, I always enjoy looking at globular clusters and kind of imagining what it would be like if you were on a planet in the center of that with all these stars around and the very dense concentration of very old stars. So they're always kind of fun to look at. All right, well, now we're going to look at something considerably closer than this globular cluster. And this is going to be an open cluster of stars called the Pleiades. Rick?
There we go. This is an open cluster of stars known as the Pleiades, or the Seven Sisters. This is one of the prettiest star clusters up in our night sky, and one that is visible. You've seen this yourselves. It's a very, very close star cluster to us, and you can see the bright members of this cluster very easily with your naked eye. It also looks wonderful in a pair of binoculars. It's named the Seven Sisters by the Greeks, but other civilizations also had other names for this. They all related it as to a group of sisters or brothers, or they all kind of saw it as the same thing. One of the interesting ones is the name the Japanese have for this cluster. They call it Subaru. Well, if you're all familiar with the Subaru car company and you look at their symbol is a stylized version of this star cluster. So how close is this? Well, the other galaxies and things we were looking at were millions of light years away. This is 440 light years away. So it is literally in our backyard, very, very close. So the Greeks named these stars after the daughters of Atlas. And those are the seven brightest stars, along with Atlas himself and his wife Pleiades. When you see photographs, color photographs of this star cluster, you can sometimes see some nebulosity, some cloudiness around them. That actually isn't cloudiness within the Pleiades. It's actually a cloud of gas that's moving between the Pleiades and us, and the Pleiades are making it glow like that. But I encourage everyone to go out in the night sky and try to find the Pleiades. It's very easy to find. Again, you've probably seen it yourself already and just maybe didn't know what you were looking at. And take out a pair of binoculars. It's a very spectacular star cluster to look at. Jim?
Yeah, it's a beautiful thing to look at just with the naked eye, and in particular in binoculars. And when you look at it, a lot of times people will confuse it with the Little Dipper because it almost looks like a baby Little Dipper, the shape of it and everything. But it is not the Little Dipper. The Little Dipper is up in the north, and the end of the handle, Little Dipper, is Polaris, the North Star. But Pleiades is kind of has that semblance of a Little Dipper, but it's absolutely gorgeous in a pair of binoculars or a small telescope.
Well, and some civilizations, because it has such a defined structure that you can see in the sky, some actually gave it attributed it to being its own constellation. of a small constellation, but its own constellation too.
Right. Very nice. All right, Jim, are you on or ready for M42?
Okay. What I have here is an object called the Great Nebula in Orion, and its catalog number is Messier number 42. It's also it's an example of a stellar nursery where new stars are being born south of Orion's belt. Nebula is a Greek word for cloud without any description of what the cloud is. In this case, it's a combination emission and reflection nebula, a huge cloud of mostly hydrogen gas producing new stars. Recent theories show evidence of about 1,500 stars in the clouds being formed in three 500-year groups. The oldest group of stars is about 22 million years old. There's another group about 12 million years old. And the newest group is about 500 million years old to the present era. Other massive stars have already run out of fuel in that cloud and ended life in catastrophic supernovas. Some stars are estimated at as little as 10,000 years old, including the very young open cluster known as the trapezium. And what I'm going to do now is try to show that trapezium by making a little bit of adjustment in the screen. And let's see. What I'm doing is trying to, there it is. At the center of the picture, or center lower, are the four stars that make up the trapezium, and you can watch them now build up the emission nebula. The red is hydrogen emitting energy from the ultraviolet light coming out of those four extremely hot stars, as much as 400 times as massive as our sun. But they're less than 10,000 years old. They don't have a whole lot more time to go. Now you can see as the camera does a little more work on it, we're getting a little bit of reflection and more of the light. And in a minute or so, when that gets done doing its work, building up there, that's only 2 seconds, what you're seeing there. That's 2 seconds worth of imaging, and you can still see the trapezium, and that's what's causing all of this. But what I'm going to do now is move that up to about 5 or 6 seconds, and you can see how much gas there really is there. And when I do that, I'll tell you when I'm counting it down. Okay, well, let's count down from 6 seconds. 5, 4, 3, 2, 1. That's the local area right around the trapezium. If I up that very much more than that, the whole screen would fill with intensely ionized gas in that area. There is a little bit more of a look. Now it's going to start doing it again because I changed the time. It's going to build it again. There it goes. So this gas cloud is actually the Great Orion Molecular Cloud. It actually covers the entire constellation of Orion. And where there are hot stars, there's glowing gases. So there's a lot of objects that are really interesting to look at in this area. And let me see if this will work. No, that's not going to work. Okay, where you see what looks like a fish's mouth over at the right-hand side. Just to the right of that is Messier object number 43 that he found the same night as he found this. Now you have to remember he's looking over the lights of Paris and the smoky fires from fireplaces in the houses of Paris with about a 5-inch refractor telescope. And he found not only this one, but he found one that's very tiny off to the side. I'm not even imaging long enough to pull it out. It's right outside that fish's mouth over there. So this is just one fantastic object over there, and it it's just so huge. You can look all over it. It's about 1,300 light years away from us, and it shines at about the main center part I'm looking at there is about 13 light years in diameter. And it's all shining because of the massive star creation. And there's actually over 1,000 stars in that cloud. We're just seeing the bright one. I'm going to make a change right now to a different screen. There's Orion the Hunter with one of his kills, and down in the lower third of the screen is a bright glow. That's the sword hanging from his belt, and that's the Orion Nebula. Now I'm going to change the culture. I'm going to go look and see what the Maya see there. And I'll go over to the star lore. And this is a beautiful feature of Stellarium for a free software. The fact that it does so much great things for us. And now they see that. And if you look off to the left of the picture, you may see a reddish image at Barnard's Loop there. That is all hydrogen gases being emitted by the stars there. But according to the Maya, this object, the object right in the center of that triangle, is the primordial fire. That's the fire of creation that created the earth. And the turtle that's right above that is the three belt stars. But in many Mesoamerican cultures, that's actually the tie between the heavens and the earth. And that's how we get our life forces that allow us to live. So for the Mayan culture, that nebula that you can see in a pair of binoculars is the fire that caused the creation of the earth. Okay, well, what we see there in the, I don't know why it wants to move, but it's moving on its own. Okay, there is the primordial fire, which is the bottom two knee stars. On the left is Saiph, and on the right is Rigel. And the leftmost belt star is Alnitak. And those three stars that make up the belt are called Alnitak, Alnilam, and Mintaka. And they're all three beautiful double stars to look at. They tend to be white in a telescope, but they're really attractive looking because they got littler stars around with them. But that turtle is the connection and between us and the a mystical world of where we came from. And in some Mayan pottery, they actually show the equivalent of Atlas holding up the earth with a turtle shell on his head to give him the strength to hold the earth. So there's another way of looking at Orion the Hunter.
What you're seeing live now is the star Heinz Crimson Star, or R. Leporis, as it's also commonly known as. This is a variable carbon star in the constellation Lepus. It varies in brightness from plus 5.5 to plus 11.7 about every 400 and roughly 30 days. That's a huge change in brightness. That's from visibly in the sky for the human eye to a brightness so dim that you need a fairly good telescope to see it. And it has a period of roughly 430 days. It's about 1,500 light years away, and it's 6,689 times brighter than the sun, with a surface temperature of approximately 3,000 degrees Kelvin. Now, to put that in perspective, our sun has a temperature of about 6,000 degrees Kelvin. So about twice the temperature. For that reason, we have a yellowish white sun, and at 3000 degrees Kelvin, this star is deep red. And that's why they call it the crimson star. These aren't that unusual in the sky. There's many of them, but this is one of the brightest ones. And it can be spotted, as I mentioned earlier, during its peak brightness. Now you can see it here as that bright star towards the center bottom of the screen. And it looks kind of white right now because I've overexposed it to show you the star field around it. But if I run the exposure down so that it doesn't oversaturate the camera, you can start to see that it has, let me blow it up a little bit. Now you can tell it's a very deep red color. It's a beautiful star to look at visually in a telescope. Now, why is it red? Well, there's several theories on why this star is red. One of the possible reasons is that it's evolved in its lifetime, in its evolution, to the point where it's turned into a red giant star. Red giant stars are stars that have evolved much further than our star, the sun, has for billions of years, to the point in its evolution where it's no longer burning hydrogen, it's no longer burning helium, it's no longer burning oxygen, it's now burning carbon. And it's emitting a reddish glow and blowing up immensely in size. So more than likely, this star, not only being so much brighter than the sun, is probably much, much larger than our sun as well. And some of these stars can easily be as large as the orbit of Jupiter. There's another of the well-known stars that are red giants is the star Betelgeuse, which is in the constellation of Orion that Jim was just showing you. Another possibility for this being a reddish star is that it may be throwing out clouds of dust, and those clouds of dust in its upper atmosphere could be absorbing the shorter wavelength light from the star itself and only letting the deeper reds get through. So that's another reason why it could be reddish in hue like this. But again, a very pretty star to look at in a telescope, and clearly shows that stars are not all the same color in the sky. And this is a definite example of one of the red ones. I'm back to you, Jim.
All right, thanks, Bernie. All right, so we're going to kind of wrap it up here. We've got
Okay, the object we have here is called the Flame Nebula. It's a New General Catalog 2024. It's magnitude 10 emission nebula, but that magnitude 10 characterization is a little misleading because that's the sum of all the light coming off of that concentrated at a point. So you can't see that very easily. It takes a bit of aperture on a telescope to actually pull it in well. You can see that it's actually glowing a little reddish. That because of the star that's right off the left side of the screen, it's actually sending a lot of glow in because the camera is picking up and multiplying the light that's also coming in from that star. The star is called Alnitak. It's the left belt star of Orion's belt. And it's being forced to glow by a massive amount of ultraviolet energy coming from Alnitak. It's about 1,500 light years away. The radius of that of the circle that covers most of that nebula is about 6 light years. It's also got an alternate name of the tank track, because in some scopes it looks like tank treads left in the mud, the prints. There's a bit of additional gas and dust that's between us and the flame that also makes it look like a flame. Otherwise, it would be just a single glowing object in there. There's a cluster of newly formed stars that we can't see at the center of the flame that's helping provide some of the energy, and that's because it's behind the gas. But the reason we know that is we can look at it with infrared telescopes. And when you look at it in the infrared, you can see stars behind that area. There's an estimate, the Chandra X-ray Observatory measured 800 stars in that darker area in the middle of the nebula. It's real close to the celestial equator. A lot of people a few years ago many years ago, used to have trouble with long duration film photography, taking pictures of that, because satellites, geosynchronous satellites or geostationary satellites would cross through there, because that's right around the Earth equator, and that's the celestial equator that matches it. And that's where they put the geostationary geosynchronous satellites. And so they fly a figure eight, a small figure eight shape. They don't really just stay in one place, they move a little bit. And you could see these moving kinds of objects in the middle of your 8-hour duration photograph, and it wouldn't make you very happy. That nebula has a partner called the Horsehead, that if I would go up off my screen, straight up off the screen and to the left, about the same amount I go up off the screen, I would see it. And if you're lucky, you get the right filters on, you get a good right telescope, you can see it. But when we see that picture of the Horsehead in a magazine somewhere, it looks like it's as big as your thumb, and really it's a tiny little pencil eraser on the screen when you actually get it in. And Jim, that's it for me.
All right, sounds good. Yeah, so what we're going to do now is we're going to wrap things up with an actual look at the Horsehead Nebula using the 9-inch folded refractor. So Bernie, over to you.
Okay, this is the famous Horsehead Nebula. You see it in a lot of literature and astronomy books. It's a dark nebula against a red background. So without the red background, you wouldn't actually be able to see it because it doesn't emit light of its own. It's actually a dark cloud blocking the light from the red H2 region that's emanating red glow behind it. The Horsehead Nebula is about 1,375 light years away. So it's relatively close compared to some of the other objects that we've been looking at this evening. It was first recorded in 1888 by a Scottish astronomer, Wilhelmina Fleming, on a photographic plate that was later discovered at the Harvard College Observatory, and she was given the rights to be the first to image it. E.E. Bernard, one of the famous astronomers, described it as a dark mass with a nebulous strip extending south. This is a very difficult object to see visually in a telescope. I've personally never seen this visually looking through an eyepiece in a telescope. And I've looked through telescopes as large as 40 inches, and I still wasn't able to make it out. This is something that you really have to use a camera to push out of most telescopes that are available to amateurs today. But it is a very, very nice object if you ever get a camera and you get a chance to start imaging in the sky. Just look south or aim south of the star Alnitak, which is the easternmost star in Orion's belt. It's just below that star. And once you get a camera and you aim it in that area, you will find it. Back to you, Jim.
Yeah, that is absolutely gorgeous. That is a great shot, and you know, it's relatively young. The gas, you know, right now resembles a horse head, but eventually it'll morph into probably something a little bit different. But it actually does look like a horse head, and you can blocking the starlight from behind. All right, so that's going to kind of wrap things up for tonight. What we're going to do is I'm going to just do a one last reminder of the equipment we're using and talk a little bit, and then we'll give all the astronomers a chance to say final words, and we'll wrap it up. So if you remember from, let's see, in the very beginning, we talked about the equipment, and this is just kind of a reminder of what the equipment we've been using tonight with Jim's 10-inch Schmidt Cassegrain and Malencam Exterminator. Bernie's out at our Chiricahua Astronomy Complex using the 9-inch folded refractor with the Malencam DS10C. And Rick's using a Stellaview 4-inch refractor on a G11 mount. And then we also showed some stuff from the Planetarium program, Stellarium, and Sky Safari Pro. Just something that's coming up. The next virtual star party we're going to be doing will be our Astronomy Festival in April 17th. And this one's going to be a little bit different because we're going to go for several hours, and we're going to include some solar observing, hopefully some interactive astronomy projects. So that'll be really cool for the kids. If you've got any kids that want to participate, we use NASA's Night Sky Network toolkits to demonstrate different astronomy concepts. And so we'll do that. And then we'll wrap things up with a little evening star party. Then this will all be streamed to our Facebook page. So just keep an eye on our Facebook page for any kind of updates for any events that we're doing in person or on Facebook or the web or YouTube. And also our calendar on our TucsonAstronomy.org. So on the website, there's a calendar that will list events coming up as well, both virtual and in person. And if you enjoyed this, we'd sure like to have you as a member of our Astronomy Association. So feel free to support us in that respect. So what I'd like to do now is just kind of go around the horn, give everybody a chance to say a final goodbye. And so we'll start with Bernie. Why don't you start us off with something?
Yeah, well, thanks everyone for tuning in this evening. I hope you enjoyed our little sky safari and the different objects that we've selected for you. Remember, you can always let us know if there's something that you'd like to see, and we can incorporate it into future star parties as well. And while I'm at it, I'd also like to thank Conrad and John, who have been helping me here this evening to make this work out.
Excellent. All right, Jim.
Well, this has been another fun night, getting out and letting people get introduced to their home universe. There's a lot of things up there that are beautiful to see and that are just have been there for a long time. They'll be there for a long time, and they're just there for you to look at. It's always a real pleasure to go over these things and try to let people know how much there is to learn and to see up there and to see the science going on around us.
All right, thanks, Jim. And Rick?
Yeah, and I'd just like to add, I want to encourage everyone to go outside and look up at the sky for yourself, especially on these moonless nights. And if you own a pair of binoculars, take them out and look up. I think you'll be surprised at what you see. Some of the things you saw tonight, you can clearly see through a pair of binoculars. The Orion Nebula you can see, some of these star clusters you can see. So just get out there and look up.
Excellent. All right, thanks, Rick. So yeah, we hope you guys enjoyed it tonight, and we've got some of our previous virtual events are on the on our Facebook page as well as on our YouTube channel. So check them out if you want to. And we'll see you at the next virtual event for us coming up April 17th. So everybody have a good night.